In this video, we will be learning about all the formulae related to the common emitter BJT amplifier with CE configuration. So our purpose is to find out the small signal voltage gain. I have introduced here RS, which is the internal resistance of the source. Okay. So the first step to find out the small signal voltage gain of common emitter amplifier is to draw its DC equivalent model. So as we have studied in the previous lecture, so DC equivalent model will be like this. Okay, so we have to find out various circuit parameters like VBB, IC, IBI to find out the small signal parameters RPI, GM. I have explained that. So in order to find that out, I have converted this voltage divider bias circuit into a simple self bias circuit. So that we can apply KVL easily and find out the parameters. So how it is done? First of all, how to find out VBB. The formula for VBB is VBB is equal to R2 upon R1 plus R2 into VCC. Nothing, I have just applied the voltage divider law here. So with the use of this formula, I can find out VBB. So now what is RB? RB is nothing but R1 parallel R2, that is it is R1 R2 upon R1 plus R2. Okay, so firstly, using this formula, I found out the RB and VB. So now what we will do, we will just apply the KVL in the inner loop. Okay, so that will give us minus VBB plus IB RB plus VBE on, here that VBE on exists, plus IERA, and that equal to 0. Okay, so now we know that IC is equal to beta into IB. Okay, and you can observe here this IB and this IC comes and it is equal to IE, that is IE equal to IB plus IC. Therefore IE equal to IB plus IC. Okay, so which will ultimately give us what? We will replace IC by beta IB. So IE will be equal to 1 plus beta times IB. I will be equal to 1 plus beta times IB. Okay, so this is another formula you should remember. Okay, I equal to 1 plus beta times IB. So putting this formula in this equation, we will be able to find out IB. Okay, so in various books the formula is directly as given as like this: IB is equal to VBB minus VBE divided by what? RB plus 1 plus beta times RE. Okay, it is given like this. Okay, so this is also one important formula, but my suggestion is you should not try to by heart this formula. Instead, just apply the KVL rules here. So this will allow us not to make any mistake while doing the calculations. Just try to apply the KVL instead of using this formula. Okay, so here we can get IB. From IB we will get IC, as beta will be given to us. Okay, beta will be given to us, therefore we will be getting IC. Okay, so same now if we apply to the outer loop, it will be equal to minus VCC. I will write it down. If we apply the KVL to the outer loop, it will be equal to minus VCC plus ICRC plus VCE plus IE RE equal to 0. So which will give us so that will give us VCE. Okay, so now we are having both the for both the Q point values, ICQ and VCEQ. Okay, if it is asked to find out the Q point values, you can easily find it out using all these formulae. This VBB, RB, applying the KVLs, this I is equal to 1 plus beta times IV. Using this formulae, you can easily find out the Q point values. Okay, just try to apply the KVL instead of using direct formula. So now we have got ICQ and VCQ. Now we know the small signal parameters. R pi is given as Vt upon ICQ and Gm is given as Vt upon IBQ and Gm is given as ICQ upon Vt. Vt we know it is 26 millivolt. Okay. So now we have got IBQ, ICQ. So we can find out R pi and Gm. Okay. So we know R pi and Gm what it is. Again we know that beta is equal to Gm into R pi. Okay. I will give it at equation number 1. So this is the small signal model. The work of DC equivalent model is ended. So this will be the small signal model of the common emitter amplifier. Here you can observe RS has come into play. So now what will be the Ri? Ri is the input resistance, that will be equal to RB parallel RIB. Okay. What is RIB? RIB is equal to R pi. Okay, you can observe RIB is equal to R pi. Ri is equal to RB parallel R pi. So Ri is nothing but RB parallel R pi parallel R pi. Okay. So we have got RIB, we have got R pi. Okay. So now what will be the voltage at the input? So the input voltage will be V input is equal to Ri upon Ri plus Rs into Vs, which implies that Vs is equal to Ri plus Rs upon Ri into V in. Okay, I think there is no any sort of confusion here. So what is V in? V in is nothing but IB into RIB, and that is equal to IB into R pi in this case. Okay, V in is the input resistance, input voltage. It will be IB into R pi. Okay, so now I will give it a, so now Vs will be Ri upon Rs upon Ri into IB into R pi. This will be equation number 2. Okay, so that's simple. So now what will be the output voltage? This IC flows through RC. IC RC will be the output voltage. So VO will be equal to IC RC. It's simple. Okay. So now what is the small signal voltage gain? The small signal voltage gain will be output voltage upon input voltage, that is equal to IC into RC divided by, I will directly write IB into R pi into Ri upon Ri plus Rs. From equation number 2, from this equation we have written the value of Vs. Okay, now we know IC is equal to beta into IB. So IB and IB will get cancelled. Here is phase shift. So now I will write the next page. So now AV, it will be equal to minus beta RC upon R pi in the Ri upon Ri plus Rs. Okay, so now we know that Gm is equal to Gm into R pi is equal to beta. Okay, so now by replacing beta by Gm into R pi and R pi will get cancelled, and which will give us AV is equal to minus Gm into Rc in the bracket Ri upon Ri plus Rs. Okay. So with the use of this formula, we can directly find out the small signal voltage gain of the amplifier. Okay, so if RS doesn't exist, then this term will be gone and the formula will be just AV is equal to minus GM into RC. Thank you.